So for my patron viewers, I'm going to give you the raw footage of the assembly of this little digital clock assembly so you can see the intricate work required, and I'm just going to put all the raw footage on. You guys can skip through it or whatever. Here it is. Enjoy. So I got this little kit from IC Station, and it's a digital clock with LEDs that rotate around the outside, so I thought maybe this might be an interesting little project to put together on this video. See how well it works. So here is the little circuit board. So as you can see, this is an SMD kit. There's going to be some SMD parts to mount here. It's got 4 digits, and it's got 60 LEDs that go all the way around for the seconds. So I guess it goes this way. Here's your second count. So I thought this might be a cool little project to work on. So let's build it. Looks like it runs on batteries too. Got a little battery kit here. We're gonna have a bunch of LEDs. This is gonna be full of parts, this thing. So I'm just gonna clear off some space here on my bench so that I don't lose the parts. Dump all the parts bag out here. Here's our LED displays. We have lots of red LEDs and some green ones. So this looks like it's going to be a green every 5 seconds, and the rest of them are all red. So just sorting through the parts here. And let's start building. So I'm going to work off the reference sheet here. They don't give you much in the way of instructions. It just tells you what parts go where. We'll start mounting the SMD resistors. Just have to find them all. Looks like our ICs go into sockets too for the socketable IC. But there are some surface mounted ICs here as well. There's 3 of them. And we've got some surface mount resistors. Lots of little surface mounted parts here. A buzzer. So I think we'll start with mounting the surface mounted resistors here. I'm going to need my magnifiers for sure on this thing. Let's get mounting parts. So I'm just picking through all my parts to find my surface mount resistors. We'll do those all first. So the first one we'll mount is a 200 ohm. It's going to have a marking on it of 201. Very fine number on here. I don't know if the camera's going to focus on this or not. Probably not. I generally have to be on a full wide shot for to do that. But on the top of the resistor here, there's a tiny little 201. You'll have to take my word for it that it is that. I'm using the magnifier here to see it. And this is 201. So I'm going to move the other ones off here so that they don't get bumped. And that goes into one marked R19. So I have to find the R19 spot, which is right over here. So that's going to be the first part that I mount. So what I'm going to do is I'm going to prep the board with some solder first. We'll tin each pad with solder so that it will take the component easily. Okay, we'll first open try and keep this kind of straight, sort of. Now, SMD kits are not for the faint of heart, and they're not my favorites to do, but it can be a challenge and it can be fun. So that's the whole point, right? See if we can make it fun. And I'm testing my vision. Even though I'm using this giant magnifying glass to see what I'm doing. That's one down. And the next one, R2 through R9, these are they are 4.7K. It's going to be this strip of these ones here. These ones have a marking on them. I think this is them. Nope. These are 100 ohm. There should be another bank of SMD resistors here. Oh, there they are, stuck in the bottom of the battery compartment. Okay, these ones here say 472, so 4700, 4.7. These go R through R2, 3, 4, 5, 6, 7, and 9. So R 2, 3, 4. Oh, they're not all in order either, so we have to find where they go. So R2 and 3, 4, 5, 6, 7, and 9. So these ones are going to go R2, 3, R2, R3, R4, 5, 7, and R9 is down here. Wonderful. Let's start with these. We'll just take these out one at a time. I'm not going to tin the board this time. Might make it easier if I just lay it on here. And yes, putting flex on would help, but I'm not going to do that either. This flex is messy. And there's some flex in the solder, so we'll just try it this way. Okay, that one's in place. Next is R3. which is next to it.
Are you recording?
Yes.
Phone for you.
Fine. I'll get it. Don't worry.
Okay.
For the next ones, I'm going to actually put some flux on the board so you can see how much easier it is when you use flux. So let me grab my flux. This time, we'll add some flux on here so you can see how much easier parts go down with flux rather than just use the rosin that's in. So the next one is, that was 2, 3, next one's 4 and 5. So 4 and 5 are over here, so we'll put some flux on the board here for 4 and 5. One thing about working with flux is it's sticky, so it'll help hold the parts in place while you heat them.
Except for I mounted these in the wrong place. Pay close attention. I put them on R14 and 15 instead of 4 and 5. The printing is very small, so we'll just move those over. So we'll just heat them and slide them over. That's better. And the next one is our 6 and 7 and 9. So 6 and 7 and 9. Almost in a row. Okay, the next is the 100 ohms, which are these ones here. They're marked 101, and they go in R11, 12, 13, 14, 15, 16, 17, and 18. Eleven, 12, 13, 14, 15, 16, 11, 12, 13, 14, 15, 16, 17, and 18. 11, 12, 13, 14, 15, 16, 17, 18. So all these ones here. Yeah, so all these ones in between here. These are all the 100 ohms that go in there. Did I mention how small these parts are? Obviously, this is a very good learning kit for someone who wants to learn how to mount SMD parts. So I just changed my tip on my soldering iron and got a little smaller one here, so it's a little easier to work with it. I'm going to be doing some even smaller parts in these when I start putting those ICs in. The pins on them are fairly close spaced, so I want to get a little bit smaller tip. Of course, the finer tip makes it much more easier to solder in these chip components. What I typically do is I put a bit of solder onto the iron, and then I use the actual solder to hold the component in place while I heat one side. Okay, that's got the 100 ohm resistors mounted. We've got two 1K ohm. And those are capacitors. So it must be these ones. 102, that's 1K. This goes to R8 and R20, which are these two down here. R8 and R20, and there's just one more down over here, R1. So these two go down here, R8 and R20. That one didn't want to go down very well, did it? And the last of the resistors will be R1. It's the last of these chip resistors. I'll be glad when all the chip components are mounted on this thing, because the rest of it's easy, but the chip components are the hardest to get in. Could you imagine what it would cost to buy something these days if these were being hand assembled with microscopic parts like this? It'd be cost prohibitive to assemble. Okay, that's got those ones out of the way. We have a couple of SMD capacitors to go in next. Two of them, we'll get them out of the way. And those are C5 and C6. Got to find where they go. They go on either side of the crystal here. I think that does it for the SMD parts. Oh, wait a minute, we got a couple more here. Or is this them? This is them here. That's the empty one. This is it here. C5 and C6, they go one there and one there. I think that does it. Well, it does it for these ones. There's a couple of SMD transistors and a couple of ICs to go into. Okay, that's the two SMD capacitors mounted. I've got a couple of electrolytics here that need to be mounted too, but we'll do all the, I'm going to do all the SMD parts first, just to get those things out of the way. So there's call it an SMD triode. In other words, it's a transistor. And there's 5 of one and 1 of another. So this one here is VT1, which goes on the board there. The other ones are VT2, 3, 4, 5, and 6. So we'll mount VT1 first. An SMD triode. A triode is a tube. It's okay, they're calling the LEDs Nixie tubes. Seriously. If you can see it on my sheet here. See? Super bright Nixie tube. Common anode. It's an LED. These are pretty easy to mount. You just tack down one leg and then you can work the others. Okay, so the other ones go into here, VT2, VT3, VT4, VT5, and VT6. See where they go here. So 2 of them go here, and the other 3 go over there. There's 5 of them total. problem with working with flux is it's so sticky that it gets on your tools, and then when you're trying to place components, components are sticking where you don't want them to stick to your tools. Oops. Okay, I believe I've got the SMD transistors mounted. I think that's all the SMD parts other than the 3 ICs, which we'll mount them next, because I want to get all the SMD parts taken care of, because they're the easiest ones to lose. Okay, so there's 2 of these are the same. One's a 16, or there's two with 16 pin and one with 14 pin. We've got different IC numbers, 4017 and 4069. Let's find the two ICs here. (4017) should be the other 4017. Okay, these are the two 4017s, and they're U2 and U3, which is these two here, and then U4 is the other one. So the dot is on the corner here. For these ones, I think I will put some flux down on the board just to make the attachment a little easier. So we're just going to line them up. Pin one in the correct orientation. We'll tack down the corner of each one of them first, and then we can go back and resolder them all. We tack down the one pin on the corner for each IC, therefore we can verify that all the other pins are lined up, and then solder the rest down. That'll hold it in place while we do the rest of them. More flux onto the pins. Flux does two things. It cleans and it prevents bridging. So you can't have too much of this stuff when you're working on SMD parts. Okay, those two are mounted. One more. If you bridge like I just did, just clean your iron off. You may have to put some more flux on there and just heat it and pull the iron away quickly. It will usually clear the short, which I've just done. Okay, that's got those ones done. I think I've got all of the SMD parts mounted now. So we'll start mounting the through hole parts now. It's got all the SMD stuff done. Okay, good. Now the through hole parts. We'll start the electrolytic capacitors. C11 or 25 volt. There's 3 of them. It's 100 microfarads. Here they are here. These ones here are polarity sensitive. And these go C1, C2, and C3. C1, C2, C3, and C4 is a 22 microfarad. So there's the four capacitors. we've got two 1N40, 148 diodes. Let's find them. There's a 41, 48 there. These are little glass diodes, switching diodes. So there's one. Here's the other one. So I got the two of them here. And they go to VD6 and VD7. I don't see where they go. Gotta go on here somewhere. Oh, there they go, right there. They go between the other ones. One in 4007 will be these rectifiers here. I think there's 4 of them. And then there will be one Zener as well. So these 4 go in here. Last one's the Zener diode. And it goes in here to one marked VD5. And now we're going to put in our LEDs. We'll put all the green ones in first, which go at the 5, 10, 15, 20, etc. and 60 second mark. The long lead is positive, and they're all marked with a plus, so we'll put our green LED markers in here. And that's another important thing. If you only want to have the 5-second marks, you don't have to put all the rest of them in. And then it'd only mark at the 5-second. But I want them all. I want it to count around. I think it's kind of cool watching the seconds tick by on that. That's why I wanted to build this little kit. I thought it'd be kind of fun. I've got a couple of bigger, larger that are all blue, right? But this is a small one. I thought this might be a nice little kit to demo for IC Station, which sent me this to show it off. One of their little kits that they sell. So I figured this was a nice little one to put together. So once you've got all the LEDs mounted, just bend the leads over so that they don't move before you solder them in. Hold them up flush against the board and bend the leads over. That'll hold them for soldering. And go to town and solder them in. I can probably change my tip back to the regular size one now because I'm not doing any more SMD work. The regular tip works much better for full size through hole. Puts more heat on, so we'll just let that one heat up.
Okay, that's got all the 5-second marker LEDs installed. We'll clip off the leads here, then go and install the rest of them. And rather than put them all in at once, I'm going to do them in banks of 5. Okay, red LEDs, same thing. The long lead is the positive. That one didn't go in straight. This is the tedious part, installing all these stupid LEDs. I'll do the rest of this off camera because this is taking just too long to do this part. Okay, we're down to the last 4 of the red LEDs. Getting the final components mounted here now. We've got another IC and a couple switches and a temperature sensor to mount. So I bend over the leads to hold the ICs or hold the LEDs in place while I solder them down. Okay, that has the last of the circular LEDs mounted. Now we'll mount down the switches to set it, the clock. We have 2 pin switches. We have the temperature sensor IC to go on next. This resembles a transistor, but it's actually an integrated circuit. So mount that down on the board like that. It's the only place left for it. And then we've got the crystal and the buzzer, which I might not even bother to mount. And the Atmel IC in its socket. So that's the temperature sensor. We have a crystal. Crystal goes in right here, X1. IC socket.
We have the IC to go in. Make note of the orientation. The notch is over here. And of course, we've got the 4 displays to put in. Now, some of these go in the upside down, so make note of the decimal point orientation, because one of these displays goes in the opposite way to the other 3. And that's done for a reason, so that you can have the flashing colon between them. But if you put it in upside down, it's not going to work. So that's the correct way for the LEDs to go in. We're going to solder 1 pin for each of the LEDs, just to tack it in place, so we can push them all the way down just to make sure that they're flush and that they haven't slipped. Okay, now that we're happy that the LED is mounted flush, we can go ahead and do the rest of the pins. I do believe that's all done. Oh, there's one more switch here, the reset switch. It's mounted up here. And of course there's the buzzer, which I may not mount. The buzzer goes over here on the back side of this, I believe. But I'm not in any big rush to mount the buzzer because I'm not going to be using this thing as an alarm clock. So there's a place to mount a backup battery on here. Got our DC input, plus and minus. For now, I'm just going to connect up the wires here. I'm going to power it with my power supply, but I'll just connect the DC. I don't even know what it takes for voltage. I'm suspecting it's taking 6 volts because it came with a battery box for 6 volts. But something like this you would run with a power supply anyway. But I'll just hook these wires up here for the time being for testing. I'll test it with the power supply. Good enough. We'll turn on the power supply. Find the cord for it. We'll set our power supply for 6 volts. And turn it on. Negative to negative and positive to positive. And there it is, it lights up. Oh, cool. And you can see the LEDs counting as it goes around. Now I thought it was going to be one where they actually lit up and stayed lit, but it looks like they're just going to rotate around one at a time. Probably can set this thing for, let's just see if I can set it here. So when this gets to the 60 mark, it should go to 1201. I'm trying to figure out how to set this thing momentarily. With no instructions, that is. I've noticed that a couple of my LEDs aren't lighting, so I'm just going to inspect very closely the connections to some of these ICs to make sure that one of the pins isn't not connected properly. It's affecting the first 10, right? And I believe they're all, if I look at the traces on here, they all come back and they go into this area here, which would be driven by these ICs. I'm just going to reflow these ICs here. There's a couple pins that look a little bit questionable, so I'm just going to dab some flux on In this case, quite a bit of flux. We're going to reheat these connections on these ICs. There we go. Okay, let's see while the lights light up this time. I think they're gonna be okay. We'll watch it as it goes. It's a count through them all. See if they all work. Okay, 32 is not working. We'll just double check that one in a minute. Two is not working. So just 2 and 32. So we'll check 2 and 32 out. See why those two aren't working. Okay, 2 and 32, I gotta look at those ones. Okay, putting the meter across it, number 2 does not appear to light, so I think the LED is effective. 1 lights, and 3 lights, but 2 does not light. We're gonna change out number 2. I've got some spares. Got a few spares, so we'll pull number 2 here. Easier said than done. Gonna put a bigger tip on my iron. So both number 32 and number 2 both measure to be bad with the meter, so we're just gonna replace both of them. Gotta open up the hole here to get the positive lead through. We power it up again. Number 2 should light up now. Yep, 2 is going to light up now. You'll see it. It's up here, and then we'll do the same for 32. So this one was defective. Okay, now 2 lights up. So we're going to pull number 32, which also is appearing to be bad. So we'll just heat it up and pull it off the board. There we go. And they did give us a couple spares, so it's not a big deal. Clear the solder off the board here. Just blow it. Heat it up and drop the new one in. I still got a bit of work to do on this. I'm going to have to center a lot of these LEDs, because some of them, when the solder cooled, they shifted. Okay, 32 should light up now as we get around to there. Oh, what the heck? .32 still not lighting. We'll put the meter on there. Let's see why not. Here's 31. 31 lights. 32 lights. 33 lights. It lights when I put the meter on this time. Okay, we changed the LED again. Let's see if it'll light up this time. I think we had 2 bad LEDs in a row. 32 was not lighting. 31. There we go, 32. Now all the lights are lighting. Okay, now this thing's working properly. Now I just have to figure out how to set it. Now, do the instructions tell you how to set this thing? Probably not. Let's just take a look. It says, what it says here is you get the hours and minutes, display the hours and minutes, and 60-piece LED rotating the analog second pointer. Walking. Use key to adjust hour and minute. Use key to adjust hour and minute. Use key to set clock. Room temperature testing. Display function. Display can be achieved. Makes no sense. Okay. Function S1 reset. Key S2 alarm. And S3 time set. Okay. So S3 is time set. So you press it and it just goes through the time. So you set your time. That's how you set it. Let's see if it sets to 12-hour or 24-hour time. It's 1 o'clock right now, so we'll set it to 1. See if it goes to 12 and goes to 13, or whether it goes back to 1 o'clock. So it's a 24-hour time. Okay, the looks like the time is set with the S2. The alarm is set with S3. When you press it, it'll set your alarm time, and when you release it, it'll go. Tells you it's going to go back in 4, 3, 2, 1, and then it goes back to the time. Press and hold this key and it'll go through the time. We'll set it to 1 o'clock or 1:01. And it takes forever to set the time because it only goes at 1 speed. There we go. Now it's 1:02, and it displays the temperature there for a second as it's doing the light chasing. But that's it. We'll kill some lights in here so that it shows up a bit better. It doesn't show up as well on camera as it does looking at it, that's for sure.
Did you just notice something what I just noticed? Watch when the it's like the seconds counting around have absolutely nothing to do with the time. Watch when the time changes here. It seems to change at random. I thought I noticed that when I first fired it up, that it was changing when it was like at 58 instead of at 60. Now it seems to be changing at about 4. So this should go to 104 when we get to the top of the hour here, the top of the second. It's not. There, it went at 4. Isn't that weird? So the seconds marching around don't seem to have any relation to the actual time that it changes. Isn't that interesting? If I power it down, power it back up, let's just see where they are when it changes to 1201. Now, as you can see, it's changing at like the 23 minute mark. That was where I press reset. Well, that might start it at the 0. Okay, let's just see what happens if I press reset when it hits 60. Whether that will fix the problem. And then set the time. Okay, so I just reset it. Now we'll set the time. It's interesting, it starts at 12 o'clock. Instead of midnight. Okay, so now I've set it to 107. Is it going to change when it gets to 0, or is it going to pick another random time? We'll find out pretty quick. We'll just monitor it until that, and then I can sign off on this video and we'll see whether we've got a pass or a fail. I see a bit of leakage here also showing up on camera. We're seeing some leakage through the multiplexer. Okay, it should change to 108 right now, right? No, it doesn't. See, it's going to pick at another random time. Probably about the time where it did the spin. There. So it just picks at random when you power it up. Isn't that interesting? Well, that just about sums it up. The kit is built and it's working. You can set the time with the time set buttons here. What I have noticed is that the minutes change. It has nothing to do with the rotating LEDs, as you can see. It happens at random when you turn it on. So the seconds indicator is in no way synchronized to the clock. I have a feeling that the clock is outputting a 1 second pulse, which is what's increasing the count here. The LEDs that are running around the edge of the board are controlled by these three ICs here. The clock is actually controlled by the Atmel, which has got the timing circuit in it and it's got the counters in it for the clock. But the two of them are not synchronized. So this is a good kit. Well, it teaches you how to solder SMD components, and for that I would say it's a good practice kit. It's a clock, but you know, it's unfortunately just the way it's designed. As you can see, you're not going to be synchronized with the seconds display, which kind of defeats the purpose. You expect the seconds would be synchronized so that when you get to the 60-second mark, the minutes roll over. That's what I expected it would do. I think that I have other clocks that work like this, and they're all synchronized. The seconds are synchronized to the minutes, and so forth. But hey, it was cool. It was kind of a cool kit. I'll probably hang it up somewhere and use it, but keep that in mind that the rotating second display is not tied to the synchronization of the clock. Thanks for watching.